Pre-Cal. Today's section's 5.2 in the textbook. It's on trig ratios and right triangles. You have had a little bit of experience with this in geometry. So the three that I know that you have seen before are sine, cosine, and tangent. Again, everything we do in this section deals with right triangles and right triangles alone. First of all, the word sine is spelled S-I-N-E. The abbreviation, though, on a calculator is S-I-N. Please do not pronounce it sin. It is sine. Sine is a trig ratio, meaning the opposite side of a right triangle divided by the hypotenuse. Cosine, C-O-S, is equal to the adjacent side, adjacent meaning next to, divided by the hypotenuse of the triangle. Tangent, T-A-N, is opposite over adjacent. And I'm sure you've seen the mnemonic device, SOHCAHTOA. S-O-H stands for sine, O, opposite, and then hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, and that's the TOA part. SOHCAHTOA, S-O-H-C-A-H-T-O-A. On the slide right now, you see a right triangle drawn. I'm going to name this triangle ABC. So angle B is the right angle. It really depends on the angle's perspective, from which angle you're looking from. So I'm going to start by having you look from angle A. If you are in this position in the triangle, then first off, the hypotenuse is always the easiest side to find. It's always across from the right angle. So this is the hypotenuse for this particular picture. If I am looking from the perspective of angle A, the opposite of angle A is the side that is across from that angle. So side BC in this picture would be considered the opposite. If this is the opposite, this is the hypotenuse, then this side, side AB, must be the adjacent side. The reason, again, it's called adjacent is because it's next to, it helps form angle A. So this is what we call adjacent. Those sides are labeled according to which angle you're looking from. So my suggestion is with every problem you encounter that you really do pay attention to the angle first and then go ahead and fill in the names for each of the sides. And that way you don't make a mistake. If, however, you are looking from the perspective of, let's say, angle C. If you're standing here, then the opposite of angle C is not going to be the same as the previous picture. And so that's why also it's important to look from the angle's perspective. Again, if I'm at angle C, the hypotenuse is still going to stay in the same position because it's always 100% of the time across from the right angle. The opposite side of angle C would be the side AB in this picture. So this would be considered the opposite. And then this would be considered the adjacent. And again, it helps form this angle. SOHCAHTOA. Sine opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent is opposite divided by adjacent. These three that are on this screen you may have not seen in geometry. Cosecant is spelled C-O-S-E-C-A-N-T. The abbreviation we use is CSC. Cosecant is hypotenuse divided by opposite. And that is because cosecant is the inverse of sine. Okay, next is secant. Secant is S-E-C-A-N-T. The abbreviation is S-E-C. and it stands for hypotenuse divided by adjacent. Secant is the inverse of cosine. So hypotenuse over adjacent, again, because it's the inverse of cosine, it is the cosine definition in reverse. Cotangent is COT. It is adjacent over hypotenuse, and cotangent is 1 divided by tangent. So again, these three that are currently on your screen are inverses of sine, cosine, and tangent. Once you know and understand SOHCAHTOA and the definitions for those, then and the relationship among these with the other three, then this becomes easier. So cosecant is the reciprocal of sine, so that's why it's H over O. Secant is the reciprocal of cosine, H over A, and cotangent is the reciprocal of tangent, A over H. So again, I'm going to go to the same type of picture. Got my right triangle drawn. I'm going to name it ABC, with B being the right angle. From perspective A at the top, you always go from the perspective of one of the acute angles, by the way. You'll never answer questions off of the right angle. So if I'm at standing angle A, the hypotenuse is always in the same place, so that one's easy to find. The opposite side in this picture would be the side that's across from angle A, which would be here. And then side AB in this picture would be considered adjacent. So, for example, if I had 6 here, an 8 here, and let's say a 10 here. When they ask me questions based on the trig ratios, they're going to ask you those questions based on the first 6 that I've shared with you. So they'll have to tell you what angle they're wanting you to look from. So we're going to look from angle A, and they'll write it like sine of A. And all they want you to do is use the definition of O over H. Opposite over hypotenuse. And so it's really easy. You're just going to follow the definition. Opposite is 6. Hypotenuse is 10. And then always reduce your fractions when you need to. So in this case, 2 goes into 6 3 times. 2 goes into 10 5 times. So the best answer for the sine of A in this particular right triangle is 3/5. The next trig ratio would be the cosine. Cosine of angle A in this picture can be found by doing the definition. Cosine is the same thing as adjacent over hypotenuse. Adjacent is 8. And again, that's why it's important to label the sides. Then it's really easy to fill in the ratio. Hypotenuse is 10, and then we reduce 8/10. 2 goes into 8 4 times, 2 goes into 10 5 times. Next is the tangent. The tangent of angle A can be found by doing opposite over adjacent. Opposite from angle A is the side labeled 6. Adjacent is the side labeled 8. Reduce your fraction, and that will be 3/4. Now, using the next 3, cosecant. Cosecant, CSC, again is the abbreviation. The cosecant for A would be the H divided by the O, so 10 divided by the opposite side, which is 6. Reduce your fraction, and that would be 5/3. And what I want you to notice, tying it back to what I mentioned earlier, if cosecant and sine are related and they're inverses of each other, then it should make sense as to why that this answer is 3/5 and this answer is 5/3. I can flip 3/5 upside down, which is essentially the definition, and that's the reason the answer is 5/3. And it works with the other two as well. Okay, the next one is secant. secant and cosine are inverses of each other. So we're looking for the secant of A right now. Secant of A. Secant's definition from above is the hypotenuse divided by the adjacent. Secant of A. Hypotenuse is 10. Adjacent is 8. 10 eighths reduces to 5/4. Again, check out the cosine of A. The cosine answer for A was 4/5, and the secant's answer, which is the reciprocal of cosine, is 5/4. And again, that's no coincidence. That will happen every time. And then the last one that you're going to have to answer is on cotangent. The cotangent from angle A in this particular triangle, the cotangent's definition is A over O, adjacent over hypotenuse. Adjacent here is 8, hypotenuse is 6. You are then going to reduce your fraction, and you're going to get 4/3. And then again, one more time, we're checking out the tangent's answer. We're comparing it to the cotangent's answer, and we can definitely tell that those are reciprocals. So it is really important that you keep these three ideas in mind. It's going to make it easier for you to remember as well. SOHCAHTOA, cosecant is the inverse of sine. Secant is the inverse of cosine. Cotangent is the inverse of tangent. You will answer these types of questions again when they ask you about basic trig ratios. And remember, ratio just means fraction, so they're wanting you to compare sides. Okay, next, determine the 6 basic trig ratios for the following. We've got a right triangle ABC. Again, I put angle B in the right angle's position. Side AB is marked 10 centimeters. Side BC is marked 7 centimeters. And what we're going to do is look at it from the perspective of angle C. And that should have been the directions, and I forgot that. So determine the 6 basic trig ratios of angle C of the following picture. So if this is the angle we're focused on right now, from this perspective, if you're here, the hypotenuse is across from the right angle. So we'll go ahead and fill that in. Okay, from angle C, this side would be the opposite. And this side would be the adjacent. Okay, so we're looking at, or for all 6 basic trig ratios, we're looking for the sine of angle C. Sine's definition is O over H. Opposite would be 10. H, I'm not sure. And so what I need to do now is where I have a right triangle with 2 given sides, but I don't know the third, I need to use Pythagorean theorem to find the missing side. And again, I can use Pythagorean theorem. I know you've had that in the past several times, but you can only use this when it's a right triangle. So we'll go to the side and do a little bit of work, then we'll go back and plug it in. The C, remember, is the hypotenuse. That's the side we don't know. This can be A, this can be B. That doesn't matter. So you can kind of just substitute it in either position. You're going to get 10 squared plus 7 squared is equal to C squared. 10 squared is 100. 7 times 7 is 49. And this is equal to C squared. When you add the 2 together, you're going to get 149, of course, equals C squared. All right, then you're going to have to solve for C, and that's going to be you taking the square root of both sides. And then using your knowledge of radicals, we did do this in pre-cal this year. It is an Algebra 2 concept, but we did it at the beginning of the year because of the gaps from last year's learning. 149 is not a perfect square. There's no whole number times itself that will equal that. So what you'll have to do is try to find the biggest, if there is a perfect square that divides into it. So you want to do 149 divided by 4, 149 divided by 9. The next one would be 4 times 4 is 16. 149 divided by 25, that won't work. 149 divided by 36, 149 divided by 49, and you'll just have to keep trying a few more to see if you can find one. Uh, 149 divided by 64 is not a whole number. Divide it by 81, divide it by 100, and you'll have to be able to do this on your own. The next perfect square is 121, and that's too close. So what that's telling me is not only is 149 not a perfect square, but 149 is not divisible by any perfect squares, meaning I'm just going to have to stick with the radical. Like the square root of 149 is as simplified as it gets. Please do not use a decimal, because if you do that, you're just giving me a rounded answer. So you have to use a radical in this case. So you're going to go ahead and fill in the square root of 149 over here for the hypotenuse. Now this is important because the side's definition is opposite over hypotenuse. If I put in square root of 149 here, then this answer is not a really good one, because we've learned in the past you cannot leave a radical in the denominator of a fraction. It's just not simplified. So then what you'll have to do is rationalize. Again, this is something we did at the beginning of the year. You can go back in your notebook and review that if you need to. You're going to have to get rid of the radical off the bottom by rationalizing, multiplying the top and bottom by that fraction, or by that radical, I should say. So the square root of 149. So sometimes, like in this case, this one's going to be a little bit more messy than the last example I shared with you. So just expect any of this to happen. 10 times 1, radical 149. Again, don't multiply a whole number times a radicand. You multiply whole numbers together. So 10 times 1 is 10, and then you'll just have to bring over your square root of 149. On the bottom, square root of 149 times itself is just 149. It's the square root of a huge number, but when you take the square root of it, this is your result. And then the last thing you do is check to see if these whole numbers reduce, like 10 over 149, and it does not. And so this is the best simplified radical answer for the sine of c. All right, let's move to cosine next. For cosine, it's going to be adjacent over hypotenuse. Adjacent is 7. Hypotenuse is that messy radical again. We cannot leave the radical underneath the division bar, so we're going to have to do what we did on the last problem. It's going to be the same step. And then underneath it, just show that you've multiplied 7 times the 1, which is 7, radical 149. And in the denominator, you have the square root times itself, and so that's just going to give you the radicand back. Okay, so there's a good answer for the cosine. Third, we're going to find the tangent. And again, try to always go in this order. The tangent is SOHCAHTOA, O over A. Opposite is 10 in this picture. A is 7. 10 divided by 7 is a reduced fraction. So there's no work that needs to be done on this one. Next, you're going to do the cosecant. The cosecant is related to the sine. We're doing the angle C, and so I can either use the definition H over O, Or I can just look at my sign answer, since the cosecant is the reciprocal or the inverse of sine, and I can start by rewriting it and putting the denominator on top and vice versa. Okay, so that's always a good, I would do it that way. That's a quick way to show the first step. Now we can see from our problem right now, though, we have an issue. We can't leave a radical 149. And so then what you'll have to do is you'll have to rationalize. You'll have to multiply the top and the bottom by that radical. Okay? Alright, so underneath, I'm running out of room, so I'm going to skip this over. It's going to be 149 times 1, which is 149, times the square root of 149. And that does not simplify. You're just going to have to leave that alone. And then go to the denominator. 10 times 1 is 10. And then you have radical times itself. That's going to be 149. But because there's a 10 in front of it, you are going to have to remember that's multiplication. And you're going to have to keep going. Okay. And so in this case, you're going to multiply 10 times 149. That's going to be 1490. And then always again, before you call it quits, check out those numbers. In this case, it does reduce. 149 goes into both of them, which in the previous step, you should have been able to see that. Let me go back. 149 here and 149 here. Since everything's being multiplied, you could have just canceled it there. It would have saved you a step. But the final answer would be the square root of 149. And the bottom number would just be 10. So this is a good answer for cosecant. Okay, so 2 more to go. We're going to do secant next. And again, just use your knowledge. Secant's the inverse of cosine. So if this is the cosine's answer, then it should be, or make sense that we can just reverse the order of it. So we do 149 divided by 7. Radical 149. And then we rationalize. So get used to these steps because they do show up often in some of these problems. Okay. All right, keep it rolling. We've got the top as 149. Square root of 149. Denominator is going to be 7 times square root times itself is just 149, just the radicand back. You're going to multiply, or you're going to notice, this is faster, just notice that these cancel. Anything divided by itself is 1. So secant of A, final answer, is the square root of 149. Divided by 7. That's what was left. And then the sixth one, we got cotangent. Cotangent of A. Cotangent is the inverse or reciprocal of tangent. Tangent was 10 over 7, so cotangent is 7 over 10. And that is a easy fraction that's already reduced, so we can stop there. Okay. Alright, so here's my sine answer, cosine answer in simplified form, tangent, cosecant, secant, and cotangent. Those are the 6 basic trig ratios for angle C in this picture. Again, remember, when you see practice problems that only give you 2 sides, pay attention to where they are, first of all, but if it's obviously a right triangle, please use Pythagorean theorem to find the missing side before you answer the trig ratios. Alright, the second big topic is something you also did in geometry, special right triangles. If it's a 45, 45, 90 triangle, in other words, the 2 angles that are acute are congruent. If these are the same answer, then there's a special pattern to the sides. and this is something that you'll have to memorize. Across from 45 degrees is some number. Now that number can be anything, so for right now I'm just going to use a generic variable. I'm going to call it 1x. If this side's 1x, then across from this 45 degree angle is also 1x. And that should make sense because if it does have equal or congruent angles, the sides opposite those angles are also congruent. They're the same length. So if this is 10, this is 10. If this is 6.2, this is 6.2. Thirdly, the side, the hypotenuse in a 45, 45, 90 degree angle triangle is always going to be this number times the square root of 2. So it's going to be the square root of 2 times longer than the other two sides. These three ratios that I have circled right now will always work if the triangle is a true 45 degree, 90 degree triangle. Okay, we'll come back to that and do an example in a second. Second and final special right triangle. It's called special because there's patterns to it that works all the time. If it's a true 30, 60, 90, let me put, I don't know, we'll put 30 up here. Sometimes they switch it on you, so make sure you're paying attention to where they label it. So let's call this one the 60 degree angle. So we have 30 degrees, we have 60 degrees, we have 90 degrees. In a 30, 60, 90 degree triangle, the side opposite the 30 degrees, side across from, is going to be some number. I'm going to call that 1x. The side that's across from the 60 degree angle is this number times the square root of 3. And notice that this is different from this one. You have to be really careful, and you really do have to memorize the patterns. Across from 90 in this particular triangle is going to be 2 times x. So it's going to be twice as long as this side. Every time I do a problem that's a special right triangle, I always label and fill in my ratios, my special pattern ratios, so that way it kind of guides me as to how to find x. Okay, so here's how this is going to work. Let me use these pictures. Let's say you had a 5 here. Okay, and it's 5 feet. If it's a 45, 45, 90 triangle, and this is 5 feet, then this side is also going to be 5 feet, just because 1x is equal to 1x. Well, if the hypotenuse is the square root of 2 times longer than this side, and this side is 5, then all you have to do is, if x is 5, that's essentially what that's saying, x is 5, then you put 5 where the x is. And so this side would be 5 times the square root of 2 times longer. And if you'll take a second right now and just type in 5 times the square root of 2 on your calculator, you'll notice it says 7.07 on your screen. 5, 5, and 7.07. So that makes sense as to why it should be longer and a bigger number than 5, because it is the hypotenuse. So it is the square root of 2 times bigger than this. Over here in the second picture, let's say this was 12. Well, if this is 12, then that means this side is 2 times 12, and that's going to be 24. And remember, if x is 12, then you're allowed to use what you know to help you find the other parts. So that should make sense as to why that's 24, because I can substitute 12 in x's place. Likewise, I can put 12 in x's place here and call this 12 square root of 3. And then just take a second right now on your calculator and type in 12 radical 3. When you do so, you see 20.78. 20.78 is definitely smaller than 24, so my answers are fitting the pattern, but not only that, it's making logical sense because the hypotenuse has to always be the longest side. So we got a 12 side, we got a 20.78 roughly side, and we got a 24 side. Alright, so that's how you have to think about it. Now what makes it more challenging, and again this goes back to geometry, is when it's easier when I give you the side that x is equal to. But if I give you this answer first, or let's say this answer first, or this answer, then you have to think backwards in finding it. Alright, so here's what, let me show you what I mean by that. So let's say we had a 45, 45, 90 degree triangle, and it's definitely a special one. And let's say that we're given that this side is 30 inches. Because it's a special right triangle, then all these sides fit a pattern. Again, looking off your notes, across from 45 is 1x, 1x, and then x radical 2. Every single time you have a problem like this, I would suggest, highly suggest, that you fill those in. And I like to circle them just because I'm kind of, it's not a part of the original problem, I'm adding something to it. And this side's x radical 2. Alright, and then what you'll do is you'll look for the side they give you. They give you 30, and so they're telling you that this ratio, this x times the square root of 2, has to be the same as 30. And you're setting up an equation, is all you're doing. And now your goal is to solve for x. Well, to solve for x, you've got to get rid of this square root of 2 that's being multiplied by x. So you have to divide. Okay, so you'll show these steps exactly like I'm modeling to you. Trying my best to show you exactly what I want to see. And then once you do that, you realize I can't leave a radical in the bottom of a fraction. So I'm going to have to rationalize. Got another step to show. Okay, we multiply fractions straight across. This is 30 times 1. Remember, this is not a radicand. So 30 times 1 is 30. Then square root of 2. On the bottom, you're going to multiply 1 times 1 if you want. You can put a 1 there. Square root of 2 times the square root of 2 is the square root of 4. Remember, you can multiply radicands together. But the square root of 4, we know the answer to that is just a whole number. It's just 2. And so it's best if you'll give me the most simplified answer you can. Square root of 2 times the square root of 2 is just 2. And then next, you're going to check out your fraction. You're going to look to see, do these numbers reduce? And I've got 30 divided by 2. 30 divided by 2 is just 15. So I want to go ahead and simplify that, and then don't forget to drop your radical down. So this is the answer for x. This side is 15 square root of 2 inches long, and so is this one. Okay, so you will have to, in cases, look for triangles that have the angles marked. If they're marked 45, 45, 90, you must use these ratios. If your triangle is marked 30, 60, 90, you must use these three ratios to figure out the missing sides. Please be careful though. Don't assume that a triangle is 30, 60, even if it's drawn and it kind of looks like it. Unless the practice set marks it as 30 or 60, don't assume that. It could be like 32. So if it fits this bill, if it fits the exact same thing I'm sharing with you, you are allowed to use this. And if not, then just use Pythagorean theorem to find the missing side. Okay, alright, so again, this was trig ratios in right triangles. You need to know the 6 ratios, and then you also need to know how to apply them in cases where it's a 45, 45, 90 or a 30, 60, 90. And you may even have to do this before you can answer the trig stuff. Like if this is angle C, they may ask you to find sine of C. And in this case, it would be 5 divided by 5 radical 2, and you would go from there.